Hello everyone, my name is David, and in this episode of our series, I'm just going to be going over how do we find a function that'll help us find per capita capital in the steady state as a function of our parameters. Well, remember that in the steady state, capital should remain constant, so capital in the future is equal to capital today, and we'll just label it K. Same thing with consumption and output. So we'll start from our law of motion of capital, but we'll replace all the KTs and KTs plus 1 with just a normal K. So this becomes K is equal to all of that over 1 plus n. Okay? And from there, well, we're just going to solve for K as a general function of the other parameters. So from here, we're going to multiply both sides by n plus 1. Yeah, same thing. So K 1 plus n mega a k to the alpha 1 minus d k. Alright, from here we then distribute this k here and this k here. So let's rewrite this as k plus kn is equal to sigma a k to the alpha plus k minus k. Well, right off the bat, we can subtract both sides by k, remove this, like that. And then what we can do then is, in the steady state, the change in capital is always 0. So let's subtract kn from both sides. Take us to 0 is equal to a k alpha minus kd minus kn. And from there, we can do another mathematical trick where we put the KD and the KN together, essentially. D plus N K, like that. So we're going to add D plus NK to both sides, so that'll bring us to D plus NK is equal to sigma a k to the alpha. And from there, we're going to divide both sides by k to the alpha. Alright? And remembering that dividing exponents with the same base is essentially the same thing as subtracting the exponents. We know there's an invisible 1 exponent right there. So this becomes d plus n k to the 1 minus alpha is equal to, these cross out, so a. Then we'll divide both sides by d plus n. So we know that k to the 1 minus alpha is equal to sigma a over d plus n. Right? And last step, we're going to try to get rid of this by putting it to the power of its inverse, so 1 over 1 minus alpha. And we're going to do the same thing here, 1 minus alpha. And so that tells us that capital in the steady state is equal to our savings rate times our technology over depreciation plus population growth rate, all of that to 1 over 1 minus alpha, right here. This function can help tell us what the steady state level of per capita capital will be as a function of all the parameters we were given in the previous problem. So, as just a quick exercise, we should get the exact same thing we got in the last video, which is that Ks equals 100. So let's do it. Sigma was 0.1, this is 100, over 1 plus 0. All of that to the 1 over 1 minus 1/2. So this whole thing should becomes 2. This right here becomes 10, and of course 1 in the denominator, this disappears. So it goes 10 squared, which is 100. That's exactly the same thing we got before. And so, that's it. If you have any more questions, feel free to come to the ASU Tutoring Center or go see your professor. And thank you for your time.